Excellent. So, Andreas, we are now live. So, welcome everyone to our next instalment of the AI series. Thank you all for joining us. My name is Laura. I'm the marketing executive for Oxygen Digital Recruitment, and that is who is hosting the session today alongside Andreas. Just a little bit of information about Oxygen Digital. We specialize in building AI and data science teams globally. So if you do have any kind of need for any new recruitment, or you are looking for your next career move, then please do get in touch. I will add some details in the chats. Just a brief overview of Livestorm for those of you who haven't used it before. We can't see you, we can't hear you, but you are in the audience. If you do want to contact us, then please use the chat. If you've got any issues, I'll be monitoring that. If you have any questions, pop them in the questions tab and Andreas will get to them at the end of the session. And if there are any polls that are put up in the polls tab, then please feel free to vote on those as well. Again, if you do have any issues, please just pop it in the chat and I will get back to you as soon as I can. The whole event is being recorded, so you will get a version of that through via email, and also we'll be putting that up on YouTube in the next few days with closed captions. So I'll go ahead and I'll pass over to Andreas now and have a great session. Thank you.
Thank you, Laura. Hi, everybody. And let me start with sharing my screen right away. So just a second. There we
I think we might have had a bit of an issue there. Bear with me just a second. We'll bring Andreas back to the stage.
There we go.
There we go. We've got you back.
Let me try that again.
Nope, we've lost you again, Andreas. Bear with me just a second. I will send you through.
Okay. Let's see if that works now.
No, that one's not worked. Let's try it again.
So, am I in? Am I not in?
I can see you in. You're on the stage, but we can't see your screen at the moment. Back to me again.
So that's kind of interesting because it was working 2 minutes ago.
It was working just a moment ago, yes.
So maybe I should try to reconnect.
Yeah, you can give that one a go. Do you have... Let me see.
Yeah, let me try to reconnect.
Yeah, give it a go, yeah.
Maybe I need some permissions, which I didn't need before the session actually started.
I'm not too sure. So for those of you that have just joined us, we're having a lovely technical difficulty. It was all running a bit too smooth for us behind the scenes. So we're just going to give this another go. That's it. We're up and running.
It is
perfect.
Fantastic. Hi, everybody. We are there, and welcome to the session about data disintegration. So this time we are going to talk about the different ways to make systems talk to each other. And let me introduce myself. I'm Andreas Oismaa. I'm the founder of a company called DataSingularity that has as its motto, make data human again. So we are working on making sure that data is back to serving the purpose of the business, which is informing the business instead of just storing bits and bytes. I've been in this profession for over 20 years, everywhere from ETL engineer, data engineer, to chief data officer and enterprise information architect. So I've seen a lot of data-related projects. I've seen them fail. I've seen them succeed. but mostly I've seen them fail. And it's those failures that forced me to start thinking out of the box and start thinking about what could a different approach be to handling data, to integrating data, to understanding data overall. But before we begin, let's first establish, why do we even have data and why do we even have systems? For that, let's go back to 30th, where there were no computers. Everything was done on paper and on the phone. And there was Frankie that sells, and there was Joe that delivers. And when Frankie sells something, all he needs to do is call Joe and say, well, I just sold X units of product X to a customer Y. So Joe needs to deliver, which can only happen if Joe understands exactly what is meant by product X and exactly what is meant by customer Y. And you would say, why wouldn't he? Actually, there is no guarantee that two people are calling the same thing using the same words. We do it all the time. For example, Coke and Coca-Cola. Each one of us will have more than one way people refer to us. It all works between people because worst case scenario, we can ask questions. Now, of course, Frankie and Joe, they don't scale that well. So Frankie and Joe could probably process about 200 products and maybe be on a couple of calls every given hour, which is not enough to scale. Which is why today, our Frankie might be Salesforce and our Joe might be SAP. So we have applications today which can exchange millions of messages instead of 2 calls per hour, and which can handle millions of products instead of a very limited amount a human brain is able to keep track of. So applications do not understand product X or product Y. All they can do is store bits and bytes, so ones and zeros. And it's us people looking into them that give the meaning to those ones and zeros. So we need to look at the data, decipher the message to get the information. That said, the problem of calling the same thing in different ways, it didn't go away. Different processes have their own way of referring to things. Different systems support those processes, naturally adopting their ways to referring to things, which means different systems will now end up with product X in one system, grade Z in another system, material 1, 2, 3 in the third, all essentially meaning on some level, or maybe even on the same level, the same exact thing. In addition, of course, systems don't really use the labels that much. They don't like using the labels. What they do is they create identifiers, and they refer to the things using those identifiers. In order to make systems talk to each other, we need to make sure that the systems understand the way their counterparty systems refer to the things that are being talked about. In a nutshell, what we need is interoperable core, aka master reference data, to make the process chain work and to make the systems communicate to each other so we can go from sales to contract to delivery to accounting, for example. So now we know why we have data. How do we deal with those systems that all potentially and actually quite probably speak different languages? Well, between people, we can think of 4 different ways in which people who speak different languages can actually communicate. One very natural way would be to create a surrogate language, which is not a mother tongue for anyone, but everybody can learn it. It's quite easy, and everybody can use it to communicate to others. Esperanto was one such attempt. It wasn't very successful, but yet it is worth mentioning. We can just learn the other person's language. We can use the dictionary, so we won't speak the language, but we will be able to point the person to the concept that we are trying to express, and in some way, with some gesticulation, we should be understood, more or less. Or we can use an interpreter, so somebody who speaks both languages as mother tongue that can stand in front between us and translate for us, being aware of the context, aware of specific expressions, which might be very contextual to each language. So basically somebody with full understanding of the linguistics and of the context of the message that we are trying to transmit. So just those 4 ways. When it comes to systems, it's no different whatsoever. We can think of Esperanto as our great centralized, aka transactional master data management system. So one single system of record that authors the data and distributes it to all the other systems, together with what they call a global identifier. Now, every single system has the same identifier for the same product or location or customer. Now they can talk to each other using that identifier, which is fantastic because your data reconciliation effort is from now on 0, of course, till you merge with another company that does not have your centralized MDM and has no idea of your global identifiers, or till somebody develops an application without thinking that they should procure the data from a central place. In any case, to prevent this central identifier from stopping to work, you need to make sure that you keep a strict control on everybody who is creating any kind of application that handles the data. Another problem of such centralized single points of entry is that it's extremely expensive to implement. Of course, you have to change legacy systems for them to accept that global identifier. But that's only half of the problem. Another half of the problem is that this beautiful house for finance is a set of multiple cost revenue centers. For urban planning is one plot. For architecture is a set of modules. For circular economy folks, it's a set of reusable units. Who of them is right? And how do we create a single way to accommodate all of those perspectives? Well, that's a very difficult consensus, which needs to be reached on both terminology and model level. And that takes time. And that is an extremely inflexible and extremely heavyweight beast. It's basically a dinosaur. And it can cost easily $500 million to build for a big enterprise. But this is one way. Another way is learning the language. So that means that an identifier from one system, for example, SAP, is sent to another system, for example, Salesforce. Now you have SAP plant numbers in Salesforce. So SAP and Salesforce can talk to each other. Unfortunately, that only solves it for those two systems. Also, unfortunately, an identifier doesn't carry any semantics. And when we are talking about this multi-context world with different perspectives on the same real-world thing, that contextuality is simply lost, which means any change in business process, any kind of update will potentially lead to quite a difficult reconciliation and remapping and reintegration exercise. So it will work, but it is, in a way, a kind of a patch, after all. Your favorite one probably, especially if you're a data engineer, the mapping tables, where we map identifiers from one system to identifiers from the other, and we use those mapping tables to integrate or reconcile the data whenever we need a cross-system overview or we need one system to talk to the other. That requires maintenance. It is good if we can automate these mappings. It is very bad if we can't, because who is maintaining them? Engineers? What do they know? Business? How are they supposed to maintain tables? Can we transition that system into support? A lot of questions, very few answers, and ultimately, it can very easily grow to a situation where to make a system A to talk to system C, we use the mapping between system A and system B, and then the mapping between system B and system C, resulting in a nice spaghetti of mappings. Something changes, it all potentially collapses. All right, so why are we talking so much about identifiers? So how does a system refer to a thing? There is a big difference between the essence and the way we refer to the thing itself. We can make different sounds in different languages to say dog, but we all, regardless of the sound or regardless of the text, we all mean the same thing. So wouldn't it be cool if we had a system that has all of those different ways to say dog in different languages attached to the concept of dog, and every time you see a dog and you have a German person to talk to, you can click on a dog, click on German, and have Hund appear on top of it. So you can communicate about this dog with a German person. Sounds very simplistic, but when you look at system integration, that's pretty much in a nutshell what's happening. You need to just point at the right product or just point at the right customer and then start talking about volumes, contracts, whatever it is you need to express transactionally. If we could do that, we would have a system that goes deeper than just mapping identifier to identifier. We would go into having a system that understands the essence, understands how the essence is reflected in every system, and can use this understanding to translate, including the context, between the different systems or reconcile the data. In other words, we would have a fourth option of how to do the data integration, which is an interpreter. So what does it take to build an interpreter? First, you need to understand what you're talking about. If you really want something more than just putting numbers here against text there, against identifiers there, you need to understand what you're talking about, which means you need to be able to talk about your business as a set of things that exist, things that describe them, and the link between those things. Also, some of the things that describe the things, or some of the attributes that describe the things, would allow you to distinguish one instance from the other. For example, the passport number and issuing country would allow you to distinguish one person from the other. And that is, worst case scenario, how you could say that Jonah and Jonathan is the same person. Even if you don't know, but you do have passport information, that would be the way you know. Of course, every system will store its own identifiers in some column. Some keys, a combination of keys, doesn't matter. You need to know where to look for those identifiers. Once you know all of that, you can process the data, and whilst you're processing the data, you could use the real world qualifiers or the real world identifiers, such as passport number and issuing country for persons or address for locations, to reconcile the data, at the same time capturing also the identifiers that sat in different systems and storing them together with the data itself. That would allow you to create a layer of representations of the same instance of data in different source systems that you can use to basically arbitrate the exchange or reconcile the data. So this is what it is going to look like. You would have an information object, for example, dog. Then you would have single dogs. For example, my dog Sparkle. For dogs, you would define how you distinguish one dog from the other. For example, by passport number or by owner and owner's address plus name. So there will be a lot of real life keys that will allow you to distinguish one instance from the other. And you can embed them in the model so that you don't have to mention that in every script that you're creating. When you are processing the data, you would be capturing the IDs from every system the data is coming from, together with the reference to the system the data was coming from. That would allow you to create a layer in which you know the essence, but you also know all the representations. If you extract those, you will create an interoperability feed. So basically a very simple mapping or matching JSON that would allow you to put the same instance against different references used in different systems. Then, when you are processing data for your application, for example, you need to reconcile the data, or you just need to arbitrate exchange between two applications, typically your transactional data will come with master reference data identifiers like product ID, customer ID, and so forth, and then some transactional numbers. All you need to do is capture those identifiers and swap them for the reference to the essence, aka the instance. Once you've done that, regardless of how those IDs looked like, you basically created data sets that look as if they came from the same system, so they are ready to reconcile. And a great thing about this approach is that as a data engineer, this is the only one that you actually have available to you aside from creating mapping tables. Because master data management strategy on an agile project is probably way out of your hands. Integrating identifiers from one system to the other in the legacy landscape is probably not something that you can request, and is very far from agile in most companies. You can create a mapping table, of course. You can chase the business and map things together, or you could use the interpreter approach, which would give you two things: a set of master reference data, because you are ingesting it, you're harvesting it, and interoperability, so the possibility for those two systems to actually talk to each other. Now, technically speaking, how can you realize this? What we have created as DataSingularity is a free and open source set of components, actually just statically compiled Golang libraries, that allow you to ingest the data, capture those representations, and produce those feeds together with master reference data feeds for your sources as simple JSON. We are relying on semantic web approach. So you would need a triple store for that, but you don't really need to be a semantics expert for that. Why? Because it allows you to model multidimensionally. So it allows you to refer to metadata to create more metadata or to generate data. And this approach is actually very quick to build. So the typical way to deliver, or the typical timelines to deliver this, would be about a couple of weeks before you can start streaming the first data. And again, this is not talking about the technology. So would you use Databricks? Would you need to go into cloud? What do you need to do in terms of technology components? It doesn't really matter. So this is just the approach that you can build in any technology that you like. And yeah, as I said, it's free and open source. So you can reach out to me and I can show you the repository and everything. So here I just wanted to inform you about this fourth way to look at data reconciliation, which is a very nasty topic whenever it comes to agile development, unless it's already somehow done. And here I think I will stop with the presentation and I can take some questions. Okay, let's see, because right now I can't. Right, I have something in the chat. Perfect. The interpreter approach is basically an adapter design pattern for data sources. Yes, absolutely, potentially. The way I like to refer to it is, we know what data mesh is. This is information mesh. So not only do you have the way to integrate data from different sources, but you also know the meaning. So you don't only know that 5 SAP plans map to one Salesforce plot, but you also know that in Salesforce you have plots, and they are represented by 5 different cost revenue centers, each one with their own usage rules and their own descriptors. So it will allow you to integrate the two systems, but it also will allow you to drive extra conclusions by reading into the meaning of the data that's being integrated. Yeah?
Excellent.
Do we have any more questions?
Don't think we've got anything coming through at the moment. But if you'd like to kind of round off, Andreas, then we can end the session there.
Yeah, fantastic. So if you would like, please reach out to me. You know how to find me on LinkedIn. I'm absolutely available to also demonstrate in practice how this works. And if I knew that it would be only taking 25 minutes, I would have come with a demo. So sometimes you get more questions, sometimes you get less questions. But please don't be shy. Do reach out if you want to see this approach in action. Because honestly, between this and mapping tables, as data engineers, we don't have much more we can do.
Excellent. I think Alexi is typing in the chat. But as Andreas mentioned, if you do have any questions that you think of, please do reach out. And again, I think it would be great to... and Alexi just asked if you've got a link for the demo that you can share at all.
I wish I had a shareable demo right here, right now, on my action list. But Alexi, please do reach out. I'll make sure you have one.
Excellent. And yeah, that's great. So yeah, make sure everyone you check out Andreas on LinkedIn, and also feel free to have a look at Oxygen Digital as well. As mentioned, if you're looking for your next move, or perhaps you need your next recruitment drive, then please do get in touch. But thank you all very much for coming. I hope you have a lovely weekend ahead. And it was great. It was a great session today, Andreas. So thank you very much.
Thank you. Thanks, everybody.
Take care. Bye.